So the Nutanix storage fabric aggregates storage through a construct referred to as a storage pool. Storage pools are a group of physical storage devices including PCIe SSD, SSD, and HDD devices across the Nutanix cluster. Storage pools usually span multiple Nutanix nodes and expand as the cluster scales. And in most cases, only a single storage pool is needed. Containers are logical implementations of storage pools and contain groups of VMs and/or files, which Nutanix refers to as vdisks. Some configuration options, such as redundancy factor, are configured at the container level, but are actually applied at the individual VM or file level. Containers typically have a one-to-one mapping with a data store in the case of NFS or SMB. A vdisk is any file within the fabric over 512 KB in size, including VMDKS and VM hard disks. So vdisks are composed of extents, which are grouped and stored on disk as an extent group. No artificial limits are imposed on the vdisk size within the storage fabric and/or the Stargate side. Vdisk size properties are stored as 64-bit signed integers with unit sizes in bytes. This means that the theoretical maximum of a vdisk can be 2 to the 64th or 9 to the 18th or simply 9 exabytes. Any boundaries below the 9 exabyte ceiling would be due to a client-side limitation, such as the maximum VMDK size on ESXi. An extent group is a 1 megabyte or 4 megabyte piece of physically contiguous stored data where the size is dependent perhaps maybe on dedupe. This data is stored as a file on the storage device owned by the CVM. Extents are dynamically distributed among extent groups to provide data striping across nodes and/or disks to improve the performance. An extent is a 1 megabyte piece of logically contiguous data, which consists of n number of contiguous blocks, and may vary depending on guest OS block size. So extents are written, read, and modified on a sub-extent basis, also known as a slice, for granularity and efficiency. An extents slice may be trimmed when moving into cache, depending on the amount of data being read or cached at that time. And then finally, a block, sometimes called a physical record, is a sequence of bytes, usually containing some whole number of records, and having a maximum length referred to as a block size. So blocks are abstracted by the file system or database management system for use by applications and end users. So as previously mentioned, storage pools aggregate physical storage devices across all nodes and expand as the cluster scales. It can be partitioned into one or more data stores or containers where each data store can contain n number of vdisks. The data stores are then presented to the hypervisor using the standard NFS or SMB protocol for all hosted VMs. Because the hypervisor communicates to the Nutanix software exactly as it would traditional storage arrays, there is zero change to the virtual environment. So VMs are provisioned and managed as before, but without having the overhead to configure LUNs, volumes, or RAID groups. So let's quickly revisit some of the storage concepts and/or organization we've discussed earlier to see how they're layered within the storage fabric, starting with the physical layer as the base. So remember, storage pools usually span multiple Nutanix nodes and expand the cluster as it scales. Storage fabric services virtualize the physical storage by creating the logical stack, specifically the extent groups. So remember, extent groups are comprised of physically contiguous stored data. Once the extent groups have been initialized, disks are striped by creating extents from the extent groups. Again, extents are logically contiguous data, which consists of n number of contiguous blocks, and again, may vary in size depending on the guest OS block size. The extents are then presented to the hypervisor's file systems as blocks. Blocks are abstracted by the file system and consumed by VMs and their applications as files and/or vdisks. And this brings us to a close, so let's recap. You should now have the ability to identify and articulate the relationships between storage pools, containers, and vdisks as part of the storage fabric or DSF. You should also have an understanding of how the Nutanix distributed storage fabric appears to the hypervisor and guest file systems, as well as understanding the various layers and the storage elements within each layer. And finally, you've gained insight on how storage is distributed and balanced across the fabric. This concludes our discussion of the Nutanix Distributed Storage Fabric. Thanks for listening, and bye for now.